Hello. So for this problem, we're going to be working on an example of inelastic collisions. So in this scenario, an 1800 kilogram car stopped at a traffic light is struck from behind by a 900 kilogram car. After the collision, the two cars are stuck together and they move along the same path as the originally moving car. And we want to find the velocity of the entangled cars after the collision, provided that the smaller car was moving at 20 meters per second. So, for inelastic collisions, momentum is always conserved. So, the total momentum of the cars before the collision will be the same as the total momentum of the cars after the collision. So let's look at what's happening in this problem, and then let's try and identify what the question is asking us for. So first, we have one stationary car with a mass of 1,800 kilograms being struck from behind by another car weighing 900 kilograms, moving at 20 meters per second. So during inelastic collisions, both masses stick together and act as one mass. Likewise, since they act as one mass, they move at the same velocity as well. This final velocity of the combined masses is what the question is asking us for. So let's go ahead and draw a diagram of the problem. So first we have a car that stopped at a stopping light or a traffic light, and let's call this car number 1. And let's call the car that's moving behind it, that hits it from behind, car number 2. So car number 2 strikes car number 1 from behind, and it has a velocity of 20 meters per second. So let's call this velocity V2I. So what this basically says is the velocity of car 2 initially, the initial velocity of car 2. And let's call this scenario before the collision. So this is a snapshot of both the cars before the collision. And now, after the collision, the cars are stuck together. So this is car 2, and this is car 1. Now they're stuck together and they're moving at the same velocity that we'll call VF. And VF stands for final velocity. So they're both moving as one unit, and they're both moving at the same velocity that we'll call VF. So we know that the mass of car 1, which is stopped at the stoplight, is going to be 1,800 kilograms. And we know that the mass of car 2, which we'll call M2, is 900 kilograms. And we know that the initial velocity of car 2, so let's actually write that as VI2 instead of V2I, is going to be 20 meters per second. And we want to find out what the final velocity of both cars stuck together is. So now let's use our equation for conservation of momentum. So the equation for conservation of momentum is PI, which is initial momentum. I stands for initial, and P is the momentum of our system, and PF is likewise going to be the final momentum of our system. And we know that momentum is always conserved before and after the collision. So therefore, the initial momentum of both cars is going to be the same as the final momentum of both cars. So basically, the momentum always remains the same. So PI, the initial momentum of the cars before the collision, is going to be the sum of the individual momentums of both cars. So let's go ahead and write the momentum formula for each car and then add them together. So momentum is equal to mass times velocity. So the initial momentum of car 1 is going to be the mass of car 1 times the velocity of car 1. And let's call this velocity V initial, or rather V1 initial. The initial velocity of car 1 plus the momentum of car 2, which is going to be equal to the mass of car 2 times the initial velocity of car 2. And then this is going to be equal to the sum of both momentums after the collision. So if you remember, the cars are going to be entangled. So they move as one mass and they have the same velocity. So we will add up the two masses together since they act as one mass, or move as one mass in this case. We'll treat these masses as one singular mass, and then we'll multiply it by the final velocity of this combined mass. So we'll multiply it by VF. Since the cars move along the same path as the originally moving car, the velocity of the entangled car, which is VF, will have the same direction as car 2. So, which is the positive X direction, or eastward. So if we draw our coordinate plane, if we call this coordinate plane our frame of reference, this is our y-axis, this is our x-axis. So quadrant number 1 of a coordinate plane. If we use this as our frame of reference, the velocity of car 2 initially is moving along the x-axis, the positive x direction of our frame of reference. So therefore, VF, the final velocity of our combined system, is going to also be moving in the same direction. So let's keep that in mind as we move forward. So now that we have our formula, let's go ahead and plug in our information that the problem gives us and then solve for VF. So mass 1 is going to be 1,800 kilograms. 1,800 kilograms. And its initial velocity is going to be 0 meters per second. This is because it's stationary. It's not moving at this point in time. And we're going to add this momentum to the momentum of car number 2, which is going to be equal to the mass times its velocity. The mass is going to be 900 kilograms. And its velocity is going to be 20 meters per second. And this will be equal to the combined mass of both cars times the final velocity. So the combined mass of both cars is going to be 1,800 kilograms plus 900 kilograms times the final velocity, which we'll call VF. So now, at this point, it should be pretty simple to solve for VF. This side of the equation will end up equaling 0. So we can say that 900 kilograms times 20 meters per second plus 0 is going to be equal to 18,000 kilograms meters per second. And this will equal the combined mass of both cars, which is 2,700 kilograms times the final velocity. And to isolate the final velocity, to get velocity by itself on one side of the equal sign, we will divide both sides by 2,700 kilograms. And as you can see, these will cancel out, and these kilogram values will cancel out. And that will leave us with our velocity, meters per second. And so if we do the math, we should get 6.67 meters per second. And so this is the magnitude of our final velocity. To find the actual velocity, right? Because velocity has both a magnitude and a direction. To find the actual velocity, we want to add in our direction. So since we said that the velocity of car 2 is going to be equal to, or rather will have the same direction as the final velocity of both cars. And also because car 2 is initially moving in the positive x direction, we will put an I hat next to our magnitude. So what I hat means is basically it tells us which direction the car is moving, which is the positive x-axis, or positive x direction, or eastward. And then we'll write our units, meters per second, and then this will be our final velocity. Thank you for watching.